The input LED is dark. The bit reads false. And the machine is down with someone standing over your shoulder waiting. A PLC input that won't turn on is one of the most common faults you will ever chase. And it is one of the most maddening because everything else looks fine. So do not start ripping the panel apart. There is a fast, ordered checklist that finds this fault in minutes. I will give you the one mismatch that catches almost everyone first, then the field device, then power and wiring, and then the single check that tells you instantly whether the problem is out in the field or inside your program. Let's find it. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC input, wiring, and the rest of this video free, right in your browser. No hardware, no install. The link is in the description. Click the link in the description to try it free. Now back to the dead input. Start with the number one reason a PLC input never turns on at all. A syncing versus sourcing mismatch. This one is brutal because the sensor looks perfectly healthy. Here is the trap. A PNP sensor sources current, it pushes current out. A syncing input card waits for current to be pushed into it. Pair those wrong, and there is no complete path. The PNP sensor cannot push current into a card that is also trying to push. So the input never pulls in. And the cruel part, the sensor's own output LED still lights up when it sees the target. So it looks alive, but the PLC sees nothing. The rule is simple. PNP needs a syncing input. NPN needs a sourcing input. They must be opposites. I have a full video on NPN, PNP, syncing, and sourcing. It is linked below. If the polarity matches, move to the field device itself. Is it even doing its job? Do not assume. Test it. First, does the sensor have power? Meter brown to blue. You should read your supply voltage, usually 24 volts. Second, is the target actually present? A proximity sensor with nothing in front of it is correctly reading nothing. Third, is the output actually switching? This is the real test. Put your meter on the signal wire reference to the right common. Then trigger the sensor. The voltage on that signal wire should change state as the target comes and goes. If it switches, the device is good, and your problem is downstream. If it does not switch, the sensor is dead, miswired, or unpowered. You just cut the problem in half. Now power and wiring, where most dead inputs actually die. Walk it in order. Is 24 volts present right at the input terminal? Not at the supply. At the terminal. Voltage can vanish on the way there. Next, is the common connected? An input card needs its common or return landed. Forget it, and every input on that group goes dead at once. That is a giveaway. Next, the fuse. Many input cards or field supplies sit behind a fuse, and a blown one kills the whole rack quietly. Check it. And finally, the wire itself. Is it loose in the terminal? Is it landed on the wrong point? One terminal over from where the drawing says? A wire that looks landed but is backed out of the cage clamp will fail intermittently. Tug test it. Here is the single most useful check in the whole list. Look at the input LED on the card. This one observation splits the entire problem in two. If the input LED is OFF, the problem is out in the field. Wiring, power of the device, everything we just covered. The card is not seeing voltage at its input, so the field side is where you look. But if the input LED is on and the bit still reads false in your program, stop. The field wiring is fine. The card is seeing the signal, so the problem is now inside. Check your addressing. Is the rung looking at the right input address? Check for a force. A forced-off bit will read false no matter what the field does. And check the logic feeding it. LED off means field. LED on, bit false, means program. That one split saves you an hour every time. So here is the order to walk every time. First, polarity. PNP needs syncing, NPN needs sourcing. Then prove the field device is switching with your meter. Then power and wiring at the terminal. Voltage, common, fuse, and a tug test. And then the decisive split. LED off is a field problem. LED on with a false bit is a program problem. Follow that order, and a dead input stops being a mystery. Now, go make it concrete. You can practice PLC input wiring free in the browser. Click the link in the description to start free at plcsimulationsoftware.com. Watch the signal wire switch in real time, with no hardware and no install. Subscribe, new video every Tuesday. See you in the next one.